Awakening in the dawn of light, silence fades away. Cocooned, we walk out to a cliff by the sea. Gulls soar to lofty heights. All that we are has taught reverence for the truth, the virtue of light. We aspire to gain the lofty heights. Then, not all at once, we change. The lofty heights are no more. Science is not in heaven. It is all around us.
Hi everybody, I'm Danna Oconnor from KUNR, our public radio station here at the university. I'm here on behalf of the Northern Nevada Science Coalition. Today our guest is Dr. Graeme Stevens. He is the director of the Center for Climate Sciences at the Jet Propulsion Laboratory in Pasadena. Welcome to UNR.
Well, thank you.
Now, Dr. Stevens, you're here on the UNR campus to talk about the water cycle and climate change. First of all, describe for us a little bit about your work. What do you do and why is it so important?
Okay, well, my work, I'm a scientist and I study the Earth and I study the atmosphere. And my focus of my research has to do with how the water cycle affects the climate system and how the climate system affects the water cycle. And the water cycle is really about how water rises from the oceans to the atmosphere, into the air and condenses into form clouds and rain and falls back to the earth, runs off back to the ocean and cycles through. That creates a water cycle that's quite fundamental to sustaining life on earth. And so we feel we're studying one of the most important and most telling parts of the earth system and the earth climate system.
Now, how is climate change affecting the water cycle?
Well, as the earth warms, the water cycle in turn changes. And basically most of the warming that we experience actually is derived from the change in the water cycle. The greenhouse gas, the heat-trapping gases that are increasing and building in the atmosphere, they're like a catalyst. They trigger this warming that in turn gets amplified by the change in the water cycle.
And what effect does that have on us here on the planet?
Well, that has effect that as we sort of look at how the water cycle changes, we can say certain things with certainty, but our view of the way the water cycle changes is somewhat fuzzy in general. We can say with certainty that the water in the atmosphere will increase as we warm, and that overall the planet will produce more rain and snow on the whole as it warms. But unfortunately, what we think will happen, it's a little bit fuzzy, our understanding is a little bit fuzzy, and we need to kind of fine-tune our understanding. But what we think will happen is, unfortunately, most of the increases in precipitation are already where there's plentiful rains and snow. And unfortunately, where places like the southwest, which tend to be an area of water deficit, are likely to experience greater water deficits. So there'll be winners in the water cycle and losers in the water cycle. Unfortunately, the winners of those have already got lots, and the losers of those tend to have little.
Do you think people can adapt to this change and adapt to the way they use water?
I think it's going to have to become a necessity. Like where I originally come from is Australia. Where Australia is a very dry country. It's called a sunburnt country, a dry country. Well, that society has very much adapted to the loss of water. There's certain things you can't do that we take for granted here. You don't plant lawns that absorb almost enormous amounts of water. So you can adapt. You can do certain things just in a very local scale that are more water-wise than we probably have done in the past.
What's the most important message you want people to take away from your lecture tonight? You'll be talking about the water cycle and climate change. What's the main point you want people to take away?
I think probably the main point is probably two or three things. Number one would be that warming is definitely real. It is definitely happening. There's not a question about whether it's warming. The scientific evidence clearly indicates that it's build-up of the heat-trapping gases that's driving this warming. But the main message is that we should be thinking about climate change as a water cycle change rather than warming, because that's where it really hits society. It's whether the rain patterns shift and how they shift, whether snowpack change and how that shifts. That's going to have the big impact on society. And in fact, the water resource and the scarcity of water resource is considered to be the major issue for world stability in the future. Is water and water resource and the ability for human society to be access to clean, healthy water.
Well, it's important to have folks like you speaking out about this. I have to confess, I'm not a scientist. I've never heard the term water cycle change before.
Oh, really? Well,
No.
it's fundamental. It's what makes Earth Earth. Remember, it's what makes Earth Earth. And the climate of Earth is really shaped by water, both on the surface of water and in the sky, and how it connects back and forth. That's what makes Earth Earth. That's what makes our climate. So clearly it's the driving force.
Okay, let's talk about something more fun.
Okay.
When did you first realize that you wanted to become a scientist?
I don't know. Probably when I was a young kid, I used to lay on the beach in Australia, used to do that and sunbake and get burned, which wasn't good because of all the UV radiation we didn't know about at that time, and the ozone hole, which wasn't there at that time. You look at the ocean and you sunbake, and you look at the sky and you see clouds, and it used to fascinate me. And I think that was kind of, over time, that sort of drove me to be interested in science. That sort of thing drove me interested in science. I just was interested in trying to work out how things worked, how nature worked, what made nature, Mother Nature tick, and we'll never understand that probably. But it's fun to try to figure it out.
Well, it's interesting that you fell in love with clouds first off, and then ended up working in cloud research.
Yeah, it wasn't that way. I mean, that would sort of piqued my interest in science. But I was really interested in physics and math, and I used to love physics and math and think about how things work and how you might build things and test things. And then I sort of moved back into clouds again for some reason or other.
What other advice do you have for young scientists?
I think a number of things actually. You just got to be basically inquisitive. Basically, don't necessarily accept everything that you read in a book. Just kind of figure it out. Just have. There should be an element in your mind of trying to figure out, is that really right what they're telling you? Just be questioning all the time. Question yourself in terms of whether you think it's something, your understanding of something is actually the way it ought to be. Just be questioning, be inquisitive, ask questions of yourself and things around you, and just be stimulated by what happens around you.
Let's talk about your art. You're an artist. I've seen beautiful artwork from you. You can find it online, and we have it on our poster for this lecture tonight. When did you start working in art?
Well, I started a long time ago. When I was a poor, starving student at college, I used to paint. I'm commissioned, and I used to paint, and get sort of way I worked my way through college to some degree. And then I stopped when I started working as a full-fledged scientist. And then I was in England in 2002, I should know. But back in 2002, it was a lot. There was a hiatus from painting for 20-some years. Now in 2002, I was in England, and there I was studying the topic about the man who named the clouds. And his name was Luke Howard, and he named the clouds, and it was a major event in science in some ways, because clouds were perceived as that which forever changing and could never be named. It could never be classified because it's changing all the time. You look out the sky, what do you call that cloud? They're changing all the time. So he came up with a coherent way of naming them. And it turned out that naming the clouds was considered such a sort of an event, a sort of a breakthrough in the philosophy of man. It even was described this way by some of the great philosophers of the time, that apparently it influenced the art and the art at the time. And everyone knows of Constable and Constable's famous cloud paintings. Well, apparently Constable was very much influenced by Howard, and Howard's influenced the clouds. So Constable really believed that his paintings of clouds were a documentation of weather, as much as it was art. So it got me sort of thinking and stimulated again. So I decided to do a whole series of paintings of clouds, because I was interested in, art's an expression of the world around us. You kind of use colour and form as the expression, where science is a similar parallel expression of the world around us, but there we use mathematics as a language rather than colour and art and form. So it's kind of a juxtaposition of the science and art, which is a topic I've begun to study a lot more over the last several years, and it's been fascinating me actually. And so if I ever get time away from doing science and other things, I want to get back to really studying the intersection of art and science, which has got quite a fascinating history.
It's fascinating. I'm really happy that you're here on the campus to talk about such an important topic. I'm happy to have access to your artwork as well online. I appreciate you coming to share your thoughts and knowledge with us. Thank you very much for coming to Reno, and good luck with your work.
Pleasure. Thank you.